Okay, so I just wanted to go over some of the most missed questions on this test number 2. So the most missed were number 2, number 10, and number 13. Okay, and then I'll talk about the free response. So let's look at number 2. So if g of x is equal to x plus 2 cosine x, then the equation of the tangent line to the graph of g at x equals pi over 2 is what? So if you need to write an equation of a tangent line, you need a point and a slope. So first let's find the point. To find the point, you plug in pi over 2 into g. So you would get pi over 2 plus 2 cosine of pi over 2. Well, cosine of pi over 2 is 0, so that cancels out. So your coordinate point is pi over 2 pi over 2. So now we need to find the slope, which requires us to take the derivative. So if I take the derivative of g, I would get 1 minus 2 sine x. Then I plug in my point, or my x value, pi over 2. So it would be 1 minus 2 sine of pi over 2. So sine of pi over 2 is 1. So 1 minus 2 is negative 1. So your equation is going to be y equals negative x minus pi over 2 plus pi over 2. But that is not given here. So you have to fit this equation into one of these forms. Okay, so most of these forms have y and x on the same side. So let's get it that way. So you can have y equals negative x plus pi over 2 plus pi over 2. So if you move x to the other side, you would get y plus x is equal to, well, pi over 2 plus pi over 2. Technically, this is 1/2 plus 1/2 pi. Okay, so a half plus a half is 1. So you are just left with pi, which means that your answer is C. The next one is number 10. So which of the following is the tangent line approximation of 3.9 if g of 4 is equal to 7? So if you want a tangent line approximation, you need an equation of the tangent line. Okay, so you are given your point, not 4, 4, it's 4, 7. So now you just need to find the slope. So you need g prime of 4. If you look at that table, g prime of 4 is negative 1. So you can make an equation and then plug in 3.9 in for x to do the approximation. And whenever you do that, you will get 0.1 plus 7, which is 7.1, which is B. And last but not least, we're going to look at 13. So if f of x is equal to that piecewise function, which of these statements are true? The limit exists, f is continuous at 1, and f is differentiable at 1. So let's start with the limit. The limit as x goes to 1. If you look at that piecewise function, your only boundaries are when x is equal to 1 and when x is not 1. So if you are looking for the limit, you are looking for everywhere around x, which means you will only be using this part of your piecewise function. Okay, so this covers both the right and left hand side. So remember that if a limit is to exist, then the left and right hand functions have to be equal. But in this case, we are only using one function, so we just need to see if this function exists at x equals 1, if I plug in 1. So if I plug in 1 into my function here, I will get 0 over 0. So I need to find some other way to figure out this limit. So if you factor out a 4 out of the top, and then you can factor it a little bit more because that's the difference of squares, you will notice that x minus 1's cancel. So all you're left with is the x plus 1. And if you plug in 1, you get 8. So the limit does exist. We just have to do some algebraic manipulation here. So now let's see if it's continuous. So for a function to be continuous, the limit has to exist, the function has to be defined, and then the two have to be equal to each other. So our limit exists, it equals 8. Our function is defined, but it's equal to 4. So this is not continuous. The two do not equal each other. Therefore, if it's not continuous, it is not differentiable. So your answer is 1 only. So now let's look at the free response. So the position of an object moving along the line at any time t is greater than or equal to 0 is given by the function s of t, where s is measured in feet and t is measured in seconds. So part A says find the velocity of the particle at t equals 4. So we are given position, that's s of t. So to find velocity, we just take the derivative. So the derivative of this guy would be 3t squared minus 18t. If I want the velocity at t equals 4, then I plug in 4 into this function here. Do some calculations here and you will get negative 24. Now, if you are given units, always put units. We are talking about velocity, and our units are feet and seconds, so we have feet per second. Part B says find the acceleration of the particle at t equals 4. So if we want acceleration, that is the second derivative of the position or the derivative of velocity. Okay, they're all the same thing. So if I take the derivative of velocity here, I would get 6t minus 18. If I want my acceleration at 4, I plug in 4. Do some math, and I will get 6, and then my units are going to be feet per second squared. Part C says, was the speed of the particle increasing or decreasing at t equals 4? Justify your answer. If you remember the 5 commandments, whenever a particle, the speed, it is increasing if velocity and acceleration have the same sign. It is decreasing if velocity and acceleration have different signs. So since my velocity is negative and my acceleration is positive, they have different signs. So we can say that the speed of the particle is decreasing, and then always give your time value at t equals 4, because you can say velocity is less than 0 and acceleration is greater than 0 at t equals 4. You can say because velocity and acceleration have opposite signs. The justification is kind of up to you, but you need to say something about the signs not being the same. So part D says for t greater than 0, find the acceleration when the particle changes directions. So again, think about your 5 commandments. A particle changes directions when velocity is 0, but acceleration is not. Okay, so we need to set velocity equal to 0. So 3t squared minus 18t is equal to 0. If I do some math here and factor out some values, I can find my points, my time values, when the particle changes direction. So one of them is 0, and the other one is 6. Now, it says for t greater than 0. We cannot use t equals 0 because it's not actually a change in direction. That's when the particle starts moving. Okay, so we need to find the acceleration at t equals 6. That's the point where it changes direction. So if you plug in 6 into your acceleration function here, you will get 18 feet per second squared. And that's how you do this free response.